So for these problems, we're going to have a look at some arithmetic sequences. Now, an arithmetic sequence just means that the sequence goes up or down by the same amount each time. So if you're adding 5 each time to move to the next terms, that would be an arithmetic sequence. If you're subtracting 10 each time, that would be a different arithmetic sequence, and so on. But the difference has to be fixed. So we'll have a look at some simple problems to start with. The first one says, a sequence is formed by the rule 3n plus 1. Part A says to write down the first 5 terms of the sequence, and part B says to write down the 20th term. Now, the key with any sequence is you have n values, and your n values must be natural numbers. And all that means is that they are going 1, 2, 3, 4, and so on. So they're always positive integer values. So if we want the first 5 terms for part A, we are looking when n is equal to 1, 2, 3, 4, and 5. We then have our nth term, so we can put this here, which in this case is 3n plus 1. And all you need to do is substitute in the values. So when n is 1, 3n plus 1 will be so, and so on. Okay? So when we substitute 1 in, we have 3 times 1, which is 3, plus 1, which is 4. When we substitute 2 in, 3 times 2 is 6, plus 1, 7. When we substitute 3 in, we get 10, substitute 4 in, 13, substitute 5 in, and we get 16. Now you should be able to notice with these is we don't always have to substitute after you've gotten the first few terms, and you can see, well, it's increasing by 3 each time, so you can carry on the pattern indefinitely. So therefore our first 5 terms are 4, 7, 10, 13 and 16. So what about for part B then? Well, if we want to find the 20th term, that just means n is equal to 20. So just like we did for 1 to 5, we just need to substitute it into our expression. So therefore we have 3 times 20 plus 1. 3 times 20 is 60, plus 1 gets us 61. So therefore the 20th term is 61. And you can use that method to find whichever term. You just substitute it into the nth term. So part 2, we have another arithmetic sequence, and we're told that the sequence is formed by the rule 100 minus 2n. And again, we want to write down the first 5 terms of the sequence. So it's the same process. So for part A, we are looking when n is 1, 2, 3, 4, and 5, and we're substituting it in to our nth term, which is 100 minus 2m. So if we substitute 1 into here, we end up with 98. Substitute 2, 96. Substitute 3, 94. 4, 92, and 5, 90. Again, each time we're going down by 2, so again, another example of an arithmetic sequence. So our first 5 terms are 98, 96, 94, 92, and 90. For part B, this time we want the 15th term. So we're looking when n is equal to 15, and we just need to substitute it into our sequence. So we have 100 minus 2 times 15. 2 times 15 is 30, and 100 minus 30 is equal to 70. So therefore the 15th term is equal to 70. And that's just a couple of examples of using the nth term to find the first 5 terms of 2 sequences, arithmetic sequences, and the 20th term and 15th term for the 2 sequences respectively.